Hello everybody. So let us start the second part of the module water chemistry. So in this part we will be dealing with municipal water treatment and disinfection processes. So municipal water treatment. The water that comes to our homes, they are taken from a water body like a river or a lake, and there may be many pollutants present in this water. So first it has to be treated, it has to be cleaned, and only then it can be distributed. So what are the different steps in municipal water treatment? That is what we are going to see first. The river water is first subjected to screening. Now screening is a method for removing solid impurities. All the solid impurities will be removed. Certain filter screens are kept and the water is allowed to flow through that. So all solid impurities can be removed. Second step is sedimentation. In sedimentation, what happens? The colloidal impurities are removed. You are adding alum to water, you are mixing with alum and you are allowing that to sediment. So along with the alum, all the colloidal impurities will also settle down. Then you can filter it and you can remove all the impurities. The next, now we have removed all the impurities. The next step is disinfection. Disinfection means removing the microorganisms present in water. That is a very essential part. And after disinfection, the water is taken for domestic supply, okay, distribution, either through pipelines or in water tank or somehow it is distributed. So these are the various steps in municipal water treatment. Now in these steps, one very important step is disinfection. So we will be discussing about disinfection in detail. So what is disinfection? From the word itself, disinfection, you are removing infection. So you are actually removing the infection causing microorganisms. We know that microorganisms are or cause a lot of infections, a lot of diseases to us, and they have to be removed. Filtration cannot remove microorganisms because size of the filter is too large for the microorganism. And boiling is a very good method, but it is not possible on a large scale. In our homes we can do boiling, we are doing boiling, the most effective method is boiling, but not possible on a large scale. So what are the different methods for disinfection? There are three methods that are very commonly used. One is called chlorination, ozonation and UV treatment. So these are the three different methods: chlorination, ozonation, UV treatment. Okay, so we will start with chlorination. Chlorination is the oldest technique. Okay, oldest techniques. Even centuries back, chlorination was discovered. Adding chlorine into water, that is what you are doing. Adding chlorine into water. So when chlorine reacts with water, it gives this compound HOCl, that is hypochlorous acid. And this hypochlorous acid is a very powerful germicide. It will destroy all microorganisms. So chlorination is a very simple technique. Just you have to add some chlorine to water. It produces hypochlorous acid and that destroys the microorganism. What are the factors which decide the efficiency of chlorination? How do we know whether chlorination is efficient or not? Or if the conditions change, will it affect the efficiency? So temperature of water, that is very important. Higher the temperature, better will be the efficiency of chlorination. Second point is time of contact. You have to provide enough time of contact. And finally, the point is pH of water. Ideal pH for chlorination is 5 to 7, which means weakly acidic pH. Normal waters will have weakly acidic pH. So it is the chlorination is the most ideal method for disinfection. Let us look at some of the advantages and disadvantages of chlorination. It is the most ideal disinfectant. I told you that earlier. Very little storage space is required for chlorine. It is stable and it is effective and economical. This is very important. Effective, it is also economical. Effective at all temperatures. Okay, starting from 5 degrees to about 65 degrees, it is very much effective. No technical expertise is required. You don't require skilled labor for that. Any person, any layman can do this. Only thing, they have to mix chlorine in the correct proportion. Disadvantages. What are the disadvantages? Excess chlorine gives a bad taste and odor. This is a general complaint that we always have, isn't it? Sometimes even in our water, I mean even in our houses or in the hostels or places like that. The regular complaint is excess chlorine. There is a bad taste and odor. Irritation of the mucous membrane. Excess chlorine causes irritation of the mucous membrane. Not effective in basic pH. I told you earlier, ideal pH is weakly acidic. So in basic pH, it is not effective. Forms trihalo compounds like trichloro compounds, which are carcinogenic in nature. So if water contains dissolved organic substances like benzene, phenol or its derivatives, it will form trichloro, benzene, trichlorophenol, etc., which are carcinogenic. Some parasites are resistant to chlorine. So these are some of the important disadvantages of chlorination. Again, toxic to fish and other aquatic species. That is why in aquariums, chlorinated water is not used. So one important question, explain the action of chlorine as a disinfectant, mention the merits and demerits of chlorination. This is an important question for your university examination. Other than chlorine, we can use some substances for chlorination. One such substance which is effective is called chloramine. What is chloramine? Chloramine is a product of chlorination of ammonia. Chlorine plus ammonia gives chloramine plus HCl, ClNH2. That is chloramine. Chloramine also gives hypochlorous acid when mixed with water. So you can see here ClNH2 plus H2O giving HOCl plus NH3. And same thing, even chlorine gives HOCl, chloramine also gives HOCl. HOCl is the what you call disinfectant there. But what is the difference? What is the advantage of using chloramine compared to chlorine? There are some advantages chloramine gives. First of all, it is more stable. Chloramine is more stable than chlorine and it is more lasting also. The effect of chlorination is more lasting when we use chloramine compared to chlorine. No irritating odor even in excess. No change in taste. And the another reason is it does not dissipate rapidly. Chlorine rapidly forms HOCl, but chloramine forms HOCl slowly. Okay, that is why even if you put it in excess, the chlorine released will be less. That is, HOCl formed will be less compared to the same amount of chlorine if you are using. Lower tendency to convert organic materials to carcinogenic compounds. Yeah, because the dissipation is slow and so the HOCl formed, the amount of HOCl formed will be less. In fact, the rate of formation of HOCl is less and so carcinogenic compounds formation will also be less. So another important question, what are the advantages of chlorination using chloramine? This is also a regularly asked question for university examination. Now, What happens when chlorine is added to water? Now, why we are adding chlorine to water? That is to destroy the microorganisms. Okay, but before that, many other processes take place, and the last step is the destruction of the microorganisms. So what are the different steps that take place when we add chlorine to water? Water contains many impurities. Okay, there may be many organic compounds which are dissolved. There may be many inorganic compounds which are dissolved. So chlorine first reacts with all these to form different compounds and to remove these things, that is to oxidize these things. So first thing of all, oxidation of reducing compounds. Many compounds present in water, they will get oxidized. Formation of chloroorganics or chloramines. Some amino compounds may be present in water, they will form chloramines, and then later oxidation of ammonia takes place, oxidation of these chloramines, that also takes place. So several reactions are taking place, and only after this the action against microorganisms starts. Okay, so whenever we are adding chlorine to water, we should make sure that some chlorine is left over in water. Okay, so that at a later stage, if a microorganism attack comes, it can be taken care of. Okay, if sufficient chlorine is not added, it will not be available for disinfection of microorganisms. Now all this disinfection is taking place at the pumping station. Okay, that is near to the river. So before pumping, all these steps are taking place. After pumping, once it reaches our home also, some chlorine should be available. Otherwise, if there is a microbial attack in our homes, near to our water tank, that cannot be taken into consideration. Disinfection will not be happening there. So the amount of chlorine which is used up for oxidation of compounds present in water is called chlorine demand. In the earlier thing, steps 1 to 5, 1 to 4, for all these 4 steps together, how much ever chlorine is required, that is called chlorine demand. And the amount of chlorine which will remain in water for disinfection is called residual chlorine. Remaining chlorine, that is residual chlorine. So there is a simple mathematical relationship between this residual chlorine and the chlorine that is added. Residual chlorine is equal to total chlorine minus chlorine demand. Okay, total chlorine added minus chlorine demand. We can plot a graph between the residual chlorine and the total chlorine added, and that graph is called the chlorination curve. Graph plotted between total chlorine added in the x-axis and residual chlorine in the y-axis, that is called chlorination curve, and this chlorination curve will help us to decide how much chlorine, how much amount of chlorine we have to add to water. Let us look at a sample chlorination curve. This is a sample chlorination curve. So on the x-axis is chlorine dosage. Chlorine dosage means amount of chlorine added, that is milligram per liter for ppm, and on the y-axis you have residual chlorine. Now you can see when you are adding this much, that is, this is O, this is A, so OA, this much amount of chlorine when you are adding, there is no residual chlorine found. Okay, why? Because this amount of chlorine is used up as chlorine demand for oxidizing all the compounds, organic and inorganic compounds present in water. After that, only residual chlorine starts appearing in the water. So from A to B, the residual chlorine is appearing, and once it reaches B, there is enough amount available so that then disinfection will start. Disinfection of already existing microorganisms. Okay, that will start. So for that, some chlorine is utilized till this point C. From this point onwards, if you increase the chlorine added, then the residual chlorine will continuously increase. Okay, this is the permitted level. Permitted level. Okay. Now, from this, what can we understand? What is the minimum amount of chlorine that you should add to water? That is known as the break point of chlorination. This point C is called the break point of chlorination. Okay, what does this break point tell you? So corresponding to point, suppose you draw a line downward, okay, or a vertical line downward, it will come and touch this chlorine dosage here at some value. Okay, so this much chlorine you should add to water. Minimum this much amount of chlorine you should add to water. Only then the entire purpose of chlorination will be completed. Okay, so the definition of breakpoint is like this: minimum chlorine which should be added to water such that residual chlorine will be available even after meeting the chlorine demand and disinfection of microorganisms already present. So chlorine demand means oxidation of organic and inorganic compounds. Okay. Then already some microorganisms are present. That is at the pumping station. And from the river, when you take the water, already some microorganisms are present. That should be killed. And then some excess chlorine should be available in water, so that when the water comes to our water tank, and suppose there is a microbial attack, like a nearby waste, what you call drain pipeline, from that some water seeped into our water tank, so that it will get infected, isn't it? So during that time there should be enough chlorine to destroy the microorganisms. Okay, microorganisms which are coming at a later stage should also be destroyed. So breakpoint is the minimum chlorine which should be added, so that even after meeting the chlorine demand and disinfection of microorganisms already present, some residual chlorine will be available. Now, what are the merits? What are the merits of breakpoint? Suppose I calculate that the breakpoint of chlorination is 8 milligram per liter. Then what does that mean? So when I add this 8 milligram per liter of chlorine to water, I am ensuring two things. First of all, I am ensuring that chlorination has been satisfied. Chlorination has been satisfied means all organic and inorganic compounds are oxidized and existing microorganisms are destroyed. Okay, then second thing, I am ensuring one more thing, ensures enough residual chlorine for long-term protection. So afterwards, in future, if a microbial contamination comes, then there should be enough chlorine to destroy those microorganisms. That also I can ensure. Okay, so determines whether chlorination has been satisfied or not, and also ensures enough residual chlorine for long-term protection. So this is the concept of break point of chlorination. Important question. Illustrate breakpoint chlorination with the help of a suitable graph. Give any two advantages of breakpoint chlorination. So here illustrate. You have to write the definition for the breakpoint, draw the graph, and you have to give two advantages of breakpoint chlorination. So that was chlorination, but what is dechlorination? Now I told you in the disadvantages of chlorination. What disadvantage we saw? It is toxic to fish and other aquatic species. So in aquariums we don't use chlorinated water. So what they do in aquariums is, we are getting chlorinated water only. So what we do is, it is first dechlorinated. Okay, suppose excess chlorine is there, then it has to be dechlorinated. What is dechlorination? Removal of residual chlorine from water prior to discharge to the environment. That is called dechlorination. Now suppose we are using wastewater, or we are cleaning wastewater, then you have to disinfect it, and the excess chlorine should not be present because that is toxic to the environment. So we have to dechlorinate that. How is it done? It is done by using sulfur dioxide gas or bisulfite salts. These are the two things used. For example, sulfur dioxide reacts with hypochlorous acid to give sulfuric acid and chloride ions, and bisulfite salt like sodium bisulfite reacts with hypochlorous acid to give sodium sulfate and hydrochloric acid. So this is how the excess chlorine will be in the form of hypochlorous acid that can be removed. Sulfur dioxide or bisulfate. Both are very effective. Next technique, ozonation. Next disinfection technique. So first technique was chlorination that we have seen. Next technique is ozonation. Ozonation means what? Adding ozone to water. Disinfection using ozone. Ozone is O3. So ozone decomposes to give oxygen plus nascent oxygen, and this nascent oxygen will destroy the microorganism. It's a powerful oxidizing agent and it will destroy the microorganism present. So 2 to 3 ppm of ozone is injected to the water stream. Now here one problem is that ozone is unstable. So you cannot store ozone, you have to create it, you have to synthesize it at that time. And synthesis of ozone is by electric arc discharge of air. Okay, high voltage electric arc discharge of air. That is the method for synthesis of ozone. Advantages of ozonation: it occurs faster than chlorine, it has lesser contact time, no harmful residual products are formed, no residual taste or odor for water, etc. These are the important advantages of ozonation. Disadvantages: it is highly expensive. You have to use high voltage for the synthesis, and that is very expensive. Then ozone is unstable. You cannot store it, you cannot transport it, you have to synthesize it at that time. It is called in situ synthesis. Corrosive nature: the nascent oxygen that is formed is highly corrosive. It will corrode the metallic containers which are used. Okay, mostly metallic containers are used for this purpose. That will be corroded. No residual protection. Residual protection means long-term protection. So at the time of ozonation, all the bacteria will get killed. But later, if a bacterial attack comes, we can do nothing. Ozone will not be available in the water. So no residual, that is long-term protection. These are the disadvantages of ozonation. Next is UV treatment. In UV treatment, what is done? Process is very simple. UV light is allowed to pass through water. Okay, take a UV lamp, allow light to come out, pass it through water, allow light to fall on water. So UV light means radiation with wavelength 400 to 120 nanometers. So 120 to 400 nanometers, that is UV radiation, and it is allowed to pass through water. So what will it do? It alters the DNA of the microorganism and deactivates it. Okay. It alters the DNA of the microorganism and deactivates it. Now what are the advantages of UV treatment? No chemicals are required. Okay, you don't want ozone, you don't want chlorine, you don't want chloramine, nothing. No chemicals are required. No dangerous byproducts will be formed. Okay, this is only light. Light is falling on water. No dangerous byproducts are formed. No change in taste or odor. Okay, like if you shine the light for more time, taste will change. Nothing like that. Then moderate contact time. Contact time is moderate, efficient. The process is efficient. Healthy and environmentally safe. The water is environmentally safe, not the process. The water is healthy and environmentally safe. These are some of the advantages of UV treatment. Disadvantages. What are the disadvantages? Deactivated pathogens may be reactivated on air exposure. Okay, so the pathogen, that is the microorganism, is only deactivated, it is not killed. In the other cases, in case of ozone and chlorination, the microorganism is completely destroyed. Here it is not like that, it is only deactivated. And so if you expose with air, the microorganism can become reactivated. Turbidity interferes with the disinfection. Turbid water means it will interfere because it will scatter the light. So it will interfere. Then no residual action. Residual action means long time protection. Long term protection is not there. When you shine this light, the microorganism gets deactivated. Afterwards, it can come back. Okay, no residual action. Cannot be used for municipal water treatment because it is very costly. Setting up this huge thing, you need a very large UV light source and things like that. That is going to be very costly. Expensive. It is very expensive. Okay, so these are some of the important disadvantages of disinfection by UV radiation. This is one question. Detail the principle and advantages of UV disinfection of water. Okay, one question that can be expected for your university exam.